To begin Module 6, I want to do a quick overview of what's known as the Standards for Mathematical Practices. Back in about 2010, the state of Arizona created new content standards, and as part of their content standards for mathematics for K through 12, they also adopted what's called the Standards for Mathematical Practices. There are 8 standards for grades K through 12 that help us to provide a framework for what it means to be a mathematical thinker. So these standards are expectations that we have for our public schools to instill in our children ways of thinking about mathematics that are productive and useful in their college, career, and future life. So we're going to take a quick dive because in your book Beyond Answers, which you're going to start reading this week for your R&R, Beyond Answers, it says exploring mathematical practices with young children. So just a quick overview of what these mathematical practices are, and I will argue you've been engaging in them throughout this course, but we're really going to try to highlight them in this next series of modules. All right, the first mathematical practice. We expect students to learn in their K through 12 development to make sense of problems and to persevere in solving them. That it's this challenge where students sometimes give up. They raise their hand after 1 second and say, "I need help." We want students to take time and learn to persevere in their solving. And as it says here, when presented with a problem, they can make a plan, carry out the plan, and evaluate its success. Before they can explain the problem to themselves, they can organize information. During the problem solving, persevere, never give up. They can monitor their work. They can see if their work is going to lead to a productive end. But if not, they can change the plan. That's just normal in mathematics. It's not the fact that professional mathematicians just start with a problem and walk through and solve it. Sometimes they make wrong turns or turns that don't work and they have to change the plan, and they continually ask, does this make sense? And then after, check their work and evaluate what worked and what didn't work. This is an important part of the learning process. The second mathematical practice, we expect students to learn in K through 12 mathematics to reason abstractly and quantitatively. Reason. It has been more common in math education in my career to have an expectation that students just mimic. Teachers show students what to do, and the students just mimic it without reasoning, without understanding. So notice here, I can use reasoning habits to help me contextualize and decontextualize problems. What that means is contextualize is when you take numbers and put them in a real world context. Can you help to make sense? And you're going to see this, maybe you already have, but you're really going to see it in this upcoming series of modules where when we put the mathematics in context, it actually helps us to make sense of the mathematics. Or sometimes we decontextualize. Sometimes we have a word problem and we make sense of the problem, like standards for mathematical practice number 1, but then we take the numbers and we pull them out of the context so we can just perform the mathematical computations or procedures and then put it back into context. And these reasoning habits include creating an understandable representation of the problem, considering the units involved, attending to the meaning of the quantities, and using properties to help solve problems. You're going to see that in this upcoming series of modules for sure. Number 3, construct viable arguments and critique the reasoning of others. I love this one. The expectation is not to have students just mimic, but rather the expectation is for students to construct viable arguments. Let me give you an example. You have been studying whole number algorithms like addition, subtraction, multiplication, division. What if the students could show a, let's say, 3-digit addition problem, and they could provide an argument for why their methodology works? And or they could observe, they could listen to another student's strategy, and they can offer a critique. And critique means that not critique in the sense like I'm going to tell you everything that's wrong. A critique can say something like, oh, that part makes sense. I have a question about that part, or I have a disagreement. I think there's an error in this part. All of that is part of critiquing. Notice here, I can make conjectures and critique the mathematical thinking of others. When you do that, you consider the context, you can use examples and non-examples, objects, drawings, diagrams. I hope you've seen that throughout this course, that objects, drawings, and diagrams can help us to make sense of the mathematics. And then you can critique the reasoning of others by listening to each other, comparing, identifying flawed logic. Hey, this is not a bad thing to point out flawed logic if we do it respectfully and politely. And then we ask questions to clarify or improve arguments. That's math standard number 3. Number 4, model with mathematics. Now, model in this case isn't like I'm going to model for you how to do it. Rather, model in this context is I can show how it's applied in a real world context. That's what we mean by mathematical model, the model of something real. Notice I can recognize math in everyday life and use math I know to solve everyday problems. I can make assumptions, I can estimate, I can make complex problems easier. I can identify important quantities and use tools to show their relationships. I can evaluate my answer and make changes if needed. All of these things are ways we can represent math. And you've seen this. Concrete models like our base 10 blocks, symbols, speaking, oral language, real world situations, pictures to help us to see what's going on. I hope you've been seeing that and you're going to see more. Number 5, use appropriate tools strategically. Not just use the tool, but to know when to use it and how to use it. That's the strategic part. I know when to use certain tools to help me explore and deepen my math understanding. I have a math toolbox. I can go to my math toolbox. And this is all part of the fluency. In my fluency thinking, in my math toolbox, I know that doing this or that in this context, strategically and appropriately, is better than something else. I know how, I know when, I can reason. And tools, by the way, there's lots of tools, not just like hands-on tools like rulers, protractors, or even manipulatives, but tools like a graph, a table. Tables and graphs are just helpful tools to help us to think. Number 6, I can attend to precision. I can use precision when solving problems and communicating my ideas. Precision in lots of ways. Precision in calculating precisely, precision in communicating precisely, precision in problem solving. I can calculate accurately, I can calculate efficiently. Notice that's all part of our fluency discussion. My answer matches what the problem asks me to do, estimate or find an exact answer, and then look, communicate. I can speak, read, write, and listen. I can correctly use math symbols, math vocabulary, units of measure. All of that is tied up into our discussion of precision. And then, number 7, look for and make use of structure. Now, mathematics, by just how it is, it's a structured, logical system of knowledge. And we want our students to look for that structure and make sense of that structure. And I really hope you see that come out loud and clear in this upcoming series of modules. I can see and understand how numbers and spaces are organized and put together as parts and wholes. Look at this, base 10 structure, operations and properties, terms, coefficients, and exponents. I hope you even recognize this as a tool and part of the structure that we use back with our multiplication of multi-digit numbers. We understand, and this is more geometry happening over here, dimension, location, attributes, transformation. You'll see more about that if you take Math 257 for sure. And then finally, Math Practice 8, look for and express regularity in repeated reasoning. Repeated reasoning. Now, I like to say this, sometimes in mathematics, historically, it's been more like repeated doing. You know, like homework, 1 through 79, the odds. And you just practice, 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 practice. And it's not often in those cases so much about reasoning and thinking. It's just about doing and memorizing in a rote kind of a way. And so in this case, regularity and repeated reasoning, I can notice when calculations are repeated, and then I can find more efficient methods. I hope you've seen that so far in this course when we're looking at addition, subtraction, multiplication, and division, that we have an emphasis as we build fluency to look for and express regularity and repeated reasoning so that we can make our work more efficient. Now, this doesn't happen overnight. Remember, these standards are like K through 12 standards, and so we continually work in the context of our grade level where our students are at to make this happen. All right, that's just a brief overview of the 8 mathematical practices. You'll be reading more about them in this book, and I hope recognizing when you experience them in the course that you are taking.